Section 2.6 and 2.7 we're going to do together, and they are all about ratios and proportions. So first, let's define what a ratio is. A ratio uses division to compare two quantities, and there's three ways to write a ratio. The first way is by using a colon. So for example, if I wanted to write the ratio of girls to boys in this class is 2 to 3, I can write it as 2:3. Another way to write a ratio is by using the word to. So using the previous example, I could say that the boys to girls in this class are 2 to 3, actually using the word to. And the last way to write a ratio is as a fraction. So here again, using the example from before, I can say that the boys to girls are 2/3 as a fraction like that. Always remember to write your ratios in simplest form. No matter if you used a colon, the word to, or you wrote it as a fraction, they should always be written in simplest form, meaning they should be in lowest terms. And just an added side note here, we will typically write ratios in the form of fractions. Not that it would be incorrect to write them with a colon or with the word to, but typically we will see them as fractions. Let's look at our first example. Number 1, at a crawfish fundraiser, 18 ninth grade students and 14 10th grade students worked the first shift. Part A asks us to find the ratio of 9th grade students to 10th grade students. So since the 9th grade students were listed first, I'm going to write that number first in my ratio. And again, we're going to typically write these as fractions. So to write this as a fraction, I would write 18/14, which keep in mind, we're also needing to write that in lowest terms or in simplest form. So we're looking for the greatest common factor of 18 and 14. Which again means I need to find the biggest number that goes into 14 that also goes into 18, which in this case is 2. So if I divide the numerator by 2 and the denominator by 2, I would get 9/7. So the ratio of 9th grade students to 10th grade students is 9:7. And part B asks us to find the ratio of 9th grade students to all students. So again, we're going to write it in the order that we were given. So 9th grade students was 18. And the total students we would find by adding these two numbers together, 18 plus 14, which is 32. So again, we need to put this in lowest terms. So looking for the biggest number that goes into 18 that also goes into 32, which again in this case is just 2. 18 divided by 2 is 9, and 32 divided by 2 is 16. So the ratio of 9th grade students to all of the students is 9:16. Let's continue some vocabulary. A proportion is an equation that states that two ratios are equal. And to solve proportions, you always cross multiply. You guys have done some cross multiplying with proportions before, so the next examples will just be some review. Example number 2, part A. 5 is to 15 as x is to 3, and they want us to solve for x. So first we have to set up the proportion. 5 is to 15, so 5/15 is equal to x is to 3, so x/3. Once again, we cross multiply in order to solve proportions, meaning I'm going to take 5 times 3 and the 15 times the x. So 15 times x is 15x, and it doesn't matter what order you do them, and I could have done the 5 times 3 first. And 5 times 3 is 15. So now that I have this equation set up, I'll just divide both sides by 15 to get the x by itself. So x equals 1. Part B says solve the proportion 12/h equals 3/17. So this is already set up for us, so all we're going to do is cross multiply. So I'll take the 3 times the h and the 12 times the 17. 3 times h is 3h, and 12 times 17 is 204. Now that I have the equation set up, I'll divide both sides by 3 and get h equals 68. Example 3, a backpacker in the Sierras hikes 5.5 miles in 2 hours. If the hiking rate remains the same, how far will the backpacker hike in 7 hours? Write and solve a proportion to find the answer. First, I see that the hiker went 5.5 miles in 2 hours, so I'm going to write that as a ratio, 5.5/2. Then it says, if the hiking rate remains the same, meaning he's not going to go faster or slower, how far will the backpacker hike in 7 hours? So to set up this proportion, I'm going to put the 7 across from the 2, since it was 2 hours and it's asking how far is he going to go in 7 hours. So I'm going to put the 7 across from the 2, and it is how far he's going to go that I don't know. So I'll replace that with an x. So if I cross multiply, I'm going to take 5.5 times 7 and the 2 times the x. And remember, it doesn't matter which order you do it in. So 2 times x is 2x, and 5.5 times 7 is 38.5. And then to solve this equation, I would divide both sides by 2 to get x equals 19.25. And remember, x was the number of miles that he went in 7 hours. So I'm going to put miles as my label. So the hiker would have gone 19.25, so 19.25 miles in the 7 hours. In example number 4, you're going to see the proportions get a little bit tougher. We're still going to cross multiply to solve them, but the equations that we set up are going to be a little bit more complicated. So in part A, it says 3 over x equals 9 over x minus 4. So you can see we now have an expression in the denominator of our second fraction. So again, we're still going to cross multiply, so I'm going to take the 3 times the x minus 4, but this time I have to take 3 times the x and 3 times the minus 4. I'm also going to take 9 times x to complete the cross multiplication. So I got to take 3 times that whole x minus 4. So I'm going to put the x minus 4 in parentheses, and I know that I'm going to have to distribute that 3 through. And then 9 times x is 9x. So to solve this, I will first distribute like we said before. So 3 times x is 3x, and 3 times negative 4 is negative 12. Since the negative 12 is the only constant term we have in this equation, I'm going to move the 3x over by subtracting it. So you get negative 12 equals 6x, and then we'll divide by 6 to get x equals negative 2. Now remember, you can always plug this back in, either into the proportion itself or into the equation you got after you cross multiplied to see if it worked out. Let's look at part B. X over 5 equals x minus 6 over 4. So just like before, we're going to cross multiply. So we're going to take the x times the 4 and the 5 times the x minus 6. And remember, I'm going to take 5 times that whole expression x minus 6. So I'm going to need to put parentheses around the x minus 6. So first we have x times 4, or just 4x, and then 5 times parentheses x minus 6, because I have to take the 5 times the x and the minus 6. So to start solving this, I would distribute 4x equals 5x minus 30. Since the minus 30 or the negative 30 is on the right side, I'm going to move the variables to the left side, so I'll subtract the 5x. 4 minus 5 is negative 1, so I have negative 1x equals negative 30, because these 5x's would have canceled. And I'll divide both sides by negative 1 to get x equals 30. And just like before, remember, you can always substitute this back in to make sure that it worked either in your proportion or in the equation you got after you cross multiplied. Example number 5 is just a story problem to apply proportions to. On a map, the distance between Red River Gorge and Pine Bluff is 3.8 centimeters. If the map scale is 1 centimeter is equal to 25 kilometers, estimate the actual distance between Red River Gorge and Pine Bluff. So when I see this, I see that I'm given a ratio, 1 centimeter for every 25 kilometers. So that's going to be the first ratio that I set up as 1 over 25. Reading the rest of the problem, I see that the distance between Red River Gorge and Pine Bluff is 3.8 centimeters. When I first set up my proportion, it was 1 centimeter for every 25 kilometers. So when I set up my proportion to solve this, I'm going to put the 3.8 across from the 1, since the 1 was in centimeters and the 3.8 was in centimeters. So it'd be 3.8 over x, which would be the kilometers that we are trying to find. So to set this up, I would first cross multiply 25 times 3.8 and 1 times x. 1 times x is just x. And 25 times 3.8 is equal to 95. Knowing that we were solving for the number of kilometers actually between Red River Gorge and Pine Bluff, I'll label this 95 kilometers. So that's it for this section. Make sure you write down any questions or comments that you have so that we can clarify them before we move on. I would especially take an extra look at the problems that had the expressions within the proportions, because those always give kids troubles year after year. So again, make sure you really understand those, and we can cover anything that you need to in class before we can move on. We'll see you then.